Welcome, everyone. Well, we have a special guest with us today. His name is Dr. Daniel R. Weinberger, MD, Director and CEO at the Lieber Institute for Brain Development. He's also a professor of neurology, psychiatry, neuroscience, and genetics at Johns Hopkins University. And he's going to be talking today about the placenta and what they found out in relations to schizophrenia. So I can't wait. I know, folks, we just had a conversation the other day about the placenta, and it's a really important topic. And so before we get started, make sure you want to support our podcast to share and subscribe. And let's welcome to the show, Dr. Weinberger. Welcome, sir.
Thank you very much. Nice to be with you. It's a pleasure
to have you. Thank you so much for being here. This is a fascinating topic because we've been exploring in the show a series of the importance of the perinatal period, the postnatal period, and it's getting a lot of traction over the last few years, which is great because we've learned so much. But today I want to learn a little bit more about your discoveries in the placenta, schizophrenia. What's going on here?
So, I mean, as you just commented, you know, the experiences of early human life have a profound impact on the lifetime of an individual. And it may well be that the impact of experiences in really the first couple of years of life, starting even before birth, have a disproportionate impact and the adaptations that people will make throughout their lifetime. So we were interested in this for a number of years with respect to developmental behavior disorders. And developmental behavior disorders are a collection of conditions which include very well-known early developmental problems like autism, intellectual difficulties, attention deficit hyperactivity disorder, Tourette's syndrome. But we've also come to appreciate, really in the last few decades, that even certain seemingly adult onset psychiatric problems like schizophrenia have developmental origins, that somehow the trajectory that leads eventually to the emergence of the symptoms of an illness like schizophrenia, which are very profound symptoms related to cognition, perception, and behavioral control, while they don't usually get first diagnosed in somebody with these problems till early adult life, seems to have an important early developmental aspect to it. And there were a number of signs that this was the case. For really many, many decades, it has been known that complicated pregnancies increase the risk of many developmental behavior disorders, including ADHD, autism, schizophrenia. Complicated pregnancies are not uncommon. Probably in 15 to 20% of pregnancies, there are complications that could be put stress on the developing baby. So this was something we were aware of. The other thing we were aware of, let me just give you a little background, then I'll get to the data. The other thing we were aware of was that in studies of identical twins, where one twin develops schizophrenia and one twin stays healthy, in general, most of the time, the ill twin was the second born of the identical twins. So a birth of twins, they don't come out at the exact same moment. One comes out first, the other comes out second. In general, the second twin is a little smaller. Identical twins are usually not identical in terms of their size at birth. Fraternal twins generally are healthier at birth and they come out about the same size. Identical twins, one is bigger, the other is smaller. Most of the time, if there is a schizophrenic twin among the twin pair, it's the smaller twin. One of the reasons that one twin is smaller is because most identical twins share a placenta, and one twin has more of it than the other. And so it looks like the one that had less of the placenta to its share was disadvantaged developmentally. That was one piece of data. The other piece of data is fraternal twins are two completely independent babies. They don't share the same placenta. They don't share the same umbilical cord. They don't share the same genes. Fraternal twins are the same as any sib pair born of separate pregnancies. They share, like all siblings, about half their genes, because you get half your genes from your mother, half your genes from your father, and on average, all siblings in a family share about half their genes. But what's interesting about fraternal twins is that they have about twice the likelihood that if one of them has schizophrenia, the other will have schizophrenia compared to the same probability in siblings of unrelated pregnancies. So the only difference between fraternal twins and siblings of unrelated pregnancy, there's no difference between these pairs in terms of how genetically alike they are or how genetically different they are. The difference is fraternal twins share a uterus, whereas siblings from unrelated pregnancies have totally separate intrauterine experiences. So all of this took us to the question of what is going on in the uterus that could contribute to risk? And this led us to study what is the most neglected organ in the human body, which is the placenta. The placenta is the only organ taken out of a human body that is not routinely sent to the laboratory for examination. In most instances, it's looked at very superficially to make sure it has all the appropriate arteries and veins, and then thrown out. And this has been going on for a very, very long time. It is not routinely examined in the way every other organ taken out of a human body is examined. So what we did was we said, okay, we need to start looking at genes. One of the things that's happened in all of medicine in the last 10 years is that we are living in this era of genomic medicine, where genes now are the entry points into how all of biomedical research is exploring disease, to try to understand what are the genetic pieces of disease, because genes are by definition mechanisms of disease. As I always like to say, genes are the egg, they're not the chicken. They come before everything else. And so that doesn't mean they're the only mechanisms of disease, because the environment's important. It doesn't mean that they're even the most remediable aspects of disease, but they're absolutely by definition mechanisms. So if you want to start somewhere to understand complicated problems, it really is a good starting place. So we asked the question, in part of these big studies that have been done in the last 10 years, there have been many genes, there have been thousands of genes that have been found to be risk factors for many common human conditions, from diabetes to high blood pressure, to stroke, to cancer, to schizophrenia, to bipolar disorder, to depression. And the genes for these disorders, for all these common illnesses, are in most cases not genes that give you the illness. They're genes that increase the chances that you get it. They're risk factors. They're not fate factors. So if you think about something like cholesterol, everybody knows cholesterol is a risk factor for heart disease, but it doesn't give you a heart attack. It gives you a greater risk of having a heart attack, which means you have to accumulate other risk factors to fall off the edge. A high cholesterol level pushes you a little closer to the cliff, but it doesn't all by itself push you from nowhere near the cliff to over the cliff. It's an accumulation of multiple risk factors that edges you closer and closer and closer to the cliff. Same thing with genes for diabetes, high blood pressure, most cancers, schizophrenia, autism, all these common disorders. There are many, many genes that contribute small increments in risk. So we said, okay, what about these schizophrenia genes that have been found now? There are hundreds of them that have been found as risk factors. And the assumption is people who end up manifesting the illness have more of those risk factors. We all have some of them. Every one of us have some of the what are called variations in the alphabet of genes, the DNA alphabet, that are risk factors. But most of us don't have enough of them that we fall off the cliff. So we said, okay, we now know what hundreds of these genes are related to risk for schizophrenia. Do they have anything to do with the placenta? Basically, what we found was in a complicated pregnancy, now we know complicated pregnancies are risk factors. So people who are born of complicated pregnancies have about twice a greater chance of developing schizophrenia than if they didn't have a complicated pregnancy, which is not a huge risk factor, because if the general population risk is 1 out of 100, and you have come from a complicated, now it's 2 out of 100, which is a big increase in risk, but it still is not enough by itself to account for illness, because 98% chance you won't be ill from that alone. But still, it is a substantial increment in the risk you would have had, doubles the risk at the population level if you didn't have the complicated pregnancy. So then we said, okay, what's happening in the placenta with respect to genes that are risk factors that you inherit from your parents if there's a complicated pregnancy? I want to make one thing clear for people about the placenta. Most of the placenta, this is not something to blame mothers for. You know, psychiatry has a long history of blaming mothers for many problems in children. And we've learned over the years that conditions like schizophrenia, autism, ADHD, these developmental disorders are not because of mother's behavior at all. And the placenta is mostly an organ that comes from the fetus. It mostly comes from the prenatal child. It just like the heart and the brain are fetal organs. The placenta is principally a fetal organ. So it comes from the genome of the prenatal infant. That's where it comes from. So it is not from the mother. It is from the baby. So we looked at this and we found that schizophrenia genes, when there's a complicated pregnancy, are activated, disproportionately activated in the placenta compared to all the other genes that might be activated in the placenta during a complicated pregnancy. And then we said, well, this is really fascinating. Why are these genes being turned on in the placenta? Because the fact is that we didn't think these genes had anything to do with the placenta. But it turns out that outside of the human brain, where most genes for brain disorders are turned on during development, genes for schizophrenia, outside of the brain, the place that they're second most turned on during development is in the placenta. So they have something to do with the health of the placenta. And what we showed was the more stress the placenta is under, and there are ways we could determine the stress to the placenta, which was really how much the placenta appeared to be inflamed, because the placenta is always fighting off the mother's immune system, because the mother's immune system views the placenta as an alien tissue, because it has a genome, comes from a genome, the father's genome, that's alien to the mother. And the mother's immune system is constantly investigating this placenta, which is growing in her womb, to figure out what the heck it's doing there, because the immune system doesn't recognize it. And so we showed that the more the immune system seemed to be responding in the placenta, the more these schizophrenia genes were turned on. And we did a number of subsequent studies to show that it's these genes in the placenta of schizophrenia that explain why a complicated pregnancy is a risk factor. It's because they are exaggerating the effects of schizophrenia genes. We've also looked at a number of other conditions where we know that complicated pregnancies are important in risk, including autism, ADHD, and we couldn't show the same thing that we found for schizophrenia. It may be because we need to look in different placentas or different circumstances, but this seemed to be pretty specific to the genes related to schizophrenia with respect to the placenta and early child development. So that's pretty much the story. We published a paper just 2 months ago where we went beyond what we found in the placenta, and we said, you know, when a baby is born, the first couple weeks of life, the environment that it's just left is the placental environment. And at birth, the infant is as close to the experience it had with the placenta as it's going to have in any of the rest of its life, because at birth is as close as it will ever be during the rest of its life to what it just been through with the placenta. So we said, okay, can these genes that were turned on in the placenta during complicated pregnancies that are related to risk for schizophrenia, do they have any effects that are residual in these very first weeks or months of life? And in collaboration with a group of scientists at the University of North Carolina who had done MRI scans of newborn infants to look at the development of their brains, we found that the genes in the placenta related to schizophrenia risk that were turned on during complicated pregnancies did predict the size of the brain at birth. And it also predicted the degree to which cognitive development advances in the first year of life. By 2 years of life, these effects were no longer seen because presumably were all normal children, and other factors, their environment, the genes they inherited from their parents, other factors began to take over child development. And the assumption is that the trajectory of, because these are all presumably normal children, the trajectory of child development incorporates many, many factors that lead to a more normal adaptation. But shortly right after birth, when the principal environmental influence on child development at that stage of life was the placenta, we could show that the effects of schizophrenia genes in the placenta, if the pregnancy was complicated, did show themselves in those first few weeks of postnatal life. That's pretty much the story. We're working very hard on trying to understand what the potential value of these observations might be, because ultimately we'd like to make children healthier. We'd like to make intrauterine life healthier. I like to say that in this era of genetic medicine, where everything is about genes, trying to find individual treatments for people based on their genetic backgrounds, we talk about personalized or precision medicine. In this era of very sophisticated genomic medicine, what is the treatment for a complicated pregnancy in this highly esoteric realm of genes? The treatment for a complicated pregnancy is bed rest. So there has to be a more sophisticated way to deal with placental health than just bed rest. But we're nowhere near that at the moment. But the hope is that there will be a field of placental medicine that will emerge over the next few years. There's a lot more interest now in the placenta than there used to be. And somebody once said that the link between maternal health and fetal development has been hiding in plain sight for decades. It's the placenta. So that's basically the story. There's an investigator at the Lieber Institute for Brain Development, where I work at Johns Hopkins, who is making models out of stem cells. You know, in medicine now, everybody's using stem cells to make little cellular models. And she is a scientist named Jennifer Irwin. She is making placenta models out of stem cells. And they can be differentiated. These cells can be differentiated into, almost any organ. And she's got this beautiful model of cells making tiny little placentas in a dish as a way of exploring how to make these placentas maybe healthier. And these models are quite mind-boggling. They're really quite mind-boggling. So it's a fascinating new area of science, of obstetric medicine, of child development. That's basically the story.
That's amazing. You have a great way of telling a story. That was excellent. I guess I only have maybe one or two questions, if that's all right.
Sure.
Are there any particular complicated births that stand out more than others?
So that's a very good question. I mean, the births, so what we have shown is the births that matter in this whole placenta story and schizophrenia genes are births that pose a real potential of physiological stress to the fetus. So these are things like preeclampsia, where you have high blood pressure, the mother has high blood pressure, things like premature rupture of membranes without induction of labor, very prolonged, complicated labor states, infection, serious infection, intrauterine growth restriction where the unborn baby is growing abnormally. So those kinds of events where there really seems to be a potential risk to the health of the fetus are the kinds of birth complications. Preeclampsia is not a rare birth obstetric complication, and intrauterine growth restriction is not rare. Where the baby is small for gestational age, it's called. These are not uncommon things. And most of the babies born from these things are okay. The vast majority are okay. It's important to remember that, schizophrenia, autism, they're not rare childhood events, but they're not common. Most children born even from complicated pregnancies are okay.
That's a great point. And I like the part where you made it, you reassured everybody that it wasn't deterministic. A lot of people start thinking that immediately.
No, it's very important for people to understand that most genes for common medical disorders and all the psychiatric disorders are genes that have something to do with how much at risk you are. They're not about your fate at all. And we're still very far from being able to use genes alone right now to predict somebody's individual liability for illness. We're not there. We're nowhere close to that. And the reason for that is the genes for psychiatric disorders, they're a little bit like the genes for the different flavors that people come in. So we all have some of these genes, and we don't quite understand what it takes for some of these genes in some individuals to translate into an illness, whereas in other individuals, it's just the way they are, quote unquote. We think the environment matters, but it's very hard to study the environment. I like to say that, if you think of life as a monopoly game, genes never determine how many railroads you own, or whether you have monopoly on Park Place. Genes are the roll of the dice determines what your experiences will be in Monopoly. But the genes are the go square on the board. They are the biological resources that you have to play the game with. They are the resources you have to be resilient, to take advantage of opportunities, to deal with the roll of the dice. And each of us have slightly different biological resources because none of us have exactly the same genome as anybody else. So that's why we're all individuals with unique, unique features.
I guess my last two questions, one of them you might have answered, and I apologize if you did, but it almost sounded like when you have these complicated pregnancies and then you have these genes being activated, I guess, for schizophrenia, it almost sounds like a self-defense mechanism of some capacity. Is that a fair assessment?
Well, that's a very good comment because we don't really know what it means. That's a very good comment. So when we tried to understand what was activating these genes, we looked for many other genes in the placenta that are related to immune responses and inflammation. Evidence that the placenta was dealing with physiological stress from the mother's bloodstream that it was responding to defensively. And the more it was seeming to initiate this defensive immune activation response, which is how the placenta shows that it's fighting back, okay? The more these schizophrenia genes were activated. So again, it may be that they are trying to help in the effort to fight off stress, but the more they're turned on, the more the placenta itself is under stress. That's what it looks like. They may be turned on to try to help fight the battle, but the more they are turned on, the more the placenta itself seems to be struggling in that battle. The assumption is the more that battle's going on, the more the placenta is taking its attention away from the child and putting that attention, which means energy and metabolism, into other areas.
Fascinating stuff. And I guess my last question, and maybe this is kind of a future endeavor, or for future research. But do endocrine disruptors play a role at all here? Do you see them having some kind of potential role?
Say that again, endocrine disruption?
Yeah, any kind of thing like that.
So, I mean, again, I think we don't have enough information about what the downstream effects of this are. We know, for example, that stress in the mother's bloodstream, and stress is a very vague term. Stress doesn't just mean you're anxious about something. Stress can mean that the biological molecules are in some ways disrupted, but cortisol in the mother's blood, which is a classic sign of stress, as well as immune markers in the mother's blood, a classic sign of stress, which can be physiological stress, high blood pressure, all kinds of stresses, but it can also be psychological stress in the pregnant mother, increases cortisol levels. And cortisol, which is an endocrinological, from the adrenal glands, an endocrinological response to stress, does create biological changes in the placenta. So cortisol in the mother's bloodstream is a factor in placental activation responses. So, I think again, we have a limited understanding of this because the placenta has been such a neglected organ in biomedical research that, there is a constant interaction going on by what's happening in the mother's bloodstream and what's happening in the placenta. And obviously in the mother's bloodstream, there are many endocrinological hormones that are at work.
Fascinating stuff. Dr. Weinberg, thank you so much for all the work you're doing and the research as well. We really appreciate it. We look forward to some exciting discoveries in the future.
Hopefully we'll have some.
Folks, again, Dr. Daniel Weinberger, MD, Director and CEO at the Lieber Institute for Brain Development, Professor of Neurology, Psychiatry, Neuroscience, and Genetics at Johns Hopkins University. I think we had the right guy, don't you? I think so. Thanks again, everyone. Thank you so much, Dr. Weinberg, for being here.
My pleasure, Dr. Carlos. Good to be with you.
Good to be with you. Thank you, everyone. Make sure to support our podcast, to share and subscribe.